You know, every time we step onto a plane, we're trusting these incredible pieces of engineering. But there's this other force always at play. It's invisible, it's immensely powerful, and honestly, it has the final say on every single journey. We're going to dive into exactly what that force is and how pilots have to deal with it day in and day out.
So what do you think that is? I mean, really, what's the single biggest challenge? You might think it's the complex machinery, or maybe navigating super crowded airspace. And yeah, those are definitely tough. But the biggest challenge, it's something else entirely. Yep, it's not the machine at all. The real co-pilot on every single flight isn't a person. It's the weather. It's the atmosphere itself, constantly changing and dictating the rules of the sky from the moment you push back from the gate to the second the wheels touch down.
Now, to really get our heads around this, we've got to clear up one crucial distinction right away. We hear the words weather and climate thrown around all the time, but for a pilot, the difference between them, well, it's everything.
Here's a great way to think about it. Climate is your entire wardrobe, all the clothes you own for every possible season. Weather's the outfit you actually choose to wear today. See, pilots aren't flying in the climate. They're flying right through the immediate, dynamic, and sometimes really dangerous weather of that specific moment. And that is exactly why, long before the engines even spool up, the most important part of the flight is already underway. It's called the weather briefing. This is where pilots and dispatchers turn a mountain of raw data into a solid strategy for a safe trip.
And this isn't just checking the forecast, It's basically a battle plan. A strong headwind? Okay, that means you're going to burn more fuel. See a thunderstorm on the radar? That's not just a bit of rain. It's a total no-go zone, filled with violent air currents you have to avoid. And temperature? Oh, temperature is a massive game changer.
Just think about that for a second. Hot air is way less dense than cold air. So on a really scorching hot day, the air just doesn't provide as much lift. That means the plane needs to go faster and use more runway just to get off the ground. In other words, the thermometer can literally decide if a fully loaded plane is too heavy to even take off. Crazy, right?
So you might be wondering, how on earth do you calculate anything if the weather is always changing? Well, you need a baseline, right? A universal rule book for the sky. In aviation, we call that the International Standard Atmosphere, or ISA. It's the fixed measuring stick that we measure all the daily weather chaos against.
Okay, so these are the magic numbers. This is the starting point for everything. Every performance chart, every calculation for takeoff power or landing distance, it all starts right here. So, if the actual temperature on the ground is way hotter than this standard 15 degrees Celsius, a pilot knows instantly that their plane's performance is going to be less than ideal, and they have to adjust their entire plan. All right, so the pre-flight checks are done, the plan is set, it's time to go. As the plane lifts off and starts to climb, it's heading straight into the most active, most chaotic part of our atmosphere. This layer, the troposphere, this is basically the planet's weather factory. It's where we live, and it's where pretty much all weather is born. It's a constantly churning, turbulent mix of air, moisture, and temperature changes, and it's the first big hurdle of any flight.
Okay, so let's imagine we're on the ground on a perfectly standard day, using that ISM model we talked about. We're at sea level, and it's a nice, comfortable 15 degrees Celsius. Now watch what happens as we climb.
We climb just 1 kilometer, that's about 3,300 feet, and boom, the temperature is already plummeted by 6.5 degrees. The air is getting colder and thinner fast.
And by the time we push up to 2 kilometers, wow, we're down to just 2 degrees Celsius. Any moisture in the clouds at this altitude is now a serious potential icing hazard for the wings. This predictable drop in temperature is one of the fundamental rules of flying.
So what we just witnessed, that has a name. It's called the lapse rate, and it's a core principle every single pilot knows like the back of their hand. It tells them exactly when they might need to turn on anti-icing systems, and it helps them predict how their engines will perform as they climb higher and higher into that colder air.
And believe me, that weather factory is just packed with challenges. Ice can build up on the wings, disrupting the airflow and basically destroying lift. You've got hidden air currents that cause sudden, jarring turbulence, and thick clouds can reduce visibility to absolute zero, forcing pilots to rely completely on their instruments to fly. But then, after all that climbing and maybe a few bumps, something almost magical happens. The plane punches through the top of the clouds, and the whole world changes.
You've totally felt this on a flight, right? Suddenly, everything just smooths out. The seatbelt sign dings off, and the flight becomes perfectly calm. That's not a coincidence. It's physics. We've literally left the weather factory behind us and below us.
So take a look at this. There's a really good reason why commercial jets hang out right on this boundary between the troposphere and the stratosphere. They literally climb out of all that messy, turbulent weather so they can cruise in the calm, predictable, smooth air above it. It's way more efficient, a lot more comfortable, and so much safer.
So why? What's the secret sauce that makes the stratosphere so calm? Well, it all comes down to the ozone layer. See, down in the troposphere, the air gets colder the higher you go, which makes it constantly churn and mix. But up in the stratosphere, the ozone layer absorbs sunlight and actually warms the air as you go higher. This creates a kind of lid, a temperature inversion that just stops all that weather-making churn in its tracks.
But hey, you can't just stay up in that calm paradise forever, right? The smooth cruise has to end, and that means the plane has to dive right back into the action for what is often the most demanding part of the entire flight.
That's the thing. Every single one of those beautiful, smooth flights has to end by descending right back through the troposphere. And all those weather hazards we climbed through on the way up, they're waiting for us on the way down, and they're often at their worst right near the airport.
And this is where a pilot really earns their stripes. You've got crosswinds trying to shove the airplane sideways off the runway. You might have fog or heavy rain that makes the runway completely invisible until the last few seconds. A wet runway brings the risk of hydroplaning, just like in a car. This final approach is the ultimate test of skill, technology, and weather science all coming together.
So here's the thought I want to leave you with. The next time you're sitting at the gate and hear your flight is delayed because of weather, maybe you won't just see an inconvenience. Maybe you'll see a team of pilots and meteorologists making a calculated, difficult decision, respecting the incredible power of the atmosphere. You're seeing the science of safety at work, making sure that invisible co-pilot, the weather, is always on your side.